It was fine where it was. It's the dt that needs to move. All right, so I am going to move the dt to the right. All right. There is no p in there, so I don't have to worry about moving that. Moving something that doesn't exist, the dp would be all by itself. All right. So k over 10 minus t dt. Now you don't have to write this, but there is an assumed coefficient of 1 for the dp. So I'm going to throw that in there just to kind of remind myself that I am taking the antiderivative of something on the left-hand side. It doesn't just magically become a p. It becomes a p because I'm taking the antiderivative of 1. Antiderivative of 1 normally would be x, but since the variable here is p, it would be just the p. All right. Now on the right-hand side, a little bit of a different story. Okay, this has a natural log kind of feel to it. So we can make the assumption that it would be the natural log of 10 minus t.
Why do you think it has a natural log on it?
Because anything that's in the form of constant over variable is natural log. And that's based off of this rule, d dx of the natural log of u is equal to u prime over u. All right, so if there's a function in the bottom of a fraction, it's a good bet that it's going to involve a natural log. The issue here is, if I were to take the derivative of this, it would be 1 over 10 minus t times a negative 1, right? Which is going to give me the exact opposite of what I want. So what I'm going to do is I'm just going to correct for that. I'm also going to throw the k in there because there is a constant multiplier that needs to be accounted for. And then I could just pop the plus c on at the end.
So the dt just changes into the negative.
The dt is really just notation telling us that
Oh, okay. So then where did the negative come from?
the negative came from the fact that if I were to check this by taking the derivative, I would get 1 over 10 minus t times negative 1. But there was no negative in here. So I'm correcting for that on the fly. It's basically like undoing u substitution. Oh, u substitution, jeez. Undoing the chain rule. So instead of multiplying by whatever the derivative of the inner function is, we're actually dividing by it. And so if I were to take this function divided by negative 1, it would introduce a negative 1 coefficient.
Is there any way to tell that's going to happen, or should we get in the habit of just checking all of them?
Personally, I just check it. Because there are techniques that allow you to figure it out, but they involve you writing side work, like extra steps, and it's like, well, if I just check it real quick, I can get the multiplier. So I recommend this one. All right, and so we get the plus c because, as you know, anytime you take the antiderivative, there's always a constant of integration that needs to get added on at the end. All right. So and we know that we don't have to do it to both sides because it would just get consolidated on the right hand side anyway. All right. So now we successfully have taken the antiderivative. We have a solution to the differential equation. It's in the form of p equals. Normally we would like it to be y equals, but that's not important here because it's p's and t's instead of y's and x's. This one's actually done. We don't have to go any further. They didn't give us a condition. Right? And the condition is what we would use to find the value of c. And also, we could, if they gave us a second condition, we could find the value of k. They didn't give us that, so we're looking for a general solution, which we have. It's also solved for one variable in terms of the other, so I don't have to do anything crazy with, like, converting it into exponential form or anything like that. All right? It's pretty straightforward. All right, so let's take a look at the second one. Or at least the first part of the second one, because after that I think you'll get the idea. Because I wanted to introduce you to a problem where they don't just give you the differential equation, they put it in word problem form and you have to kind of flesh out what it is. Right.
For the left side, why does dp not become like dp plus c?
You could put the plus c, but then when I bring the c over to the right hand side, it gets consolidated. Right. Now, in part A, it says the rate of change of p with respect to t. Right, so rate of change of p with respect to t. That's calculus speak for dp dt. is proportional. All right, so you might be wondering, well, what kind of proportional? Directly, inversely, jointly proportional. Bless you. If they don't say, it's direct. All right. If it's some other kind of proportionality, they would indicate that. If it's inversely proportional, they would say inversely proportional, right, or jointly. All right. So the model, bless you, is going to be in the form of y equals kx. So dp dt equals k times the thing that it's proportional to, in this case 25 minus t. Black. All right, so that's the big challenge, I think, because once you get it into the differential form, it's just a matter of finding the antiderivative. I know easier said than done. And again, there's entire courses in college that are devoted to the study of finding antiderivatives. Courses, plural. All right, so obviously it gets harder, but we're focusing on the basic stuff here. All right, kind of give you a little leg up when you are sitting in that college class. It'll be a cool feeling, I promise you. And if the speaker comes, she'll agree with this. It's a cool feeling when you're sitting in the class, looking around at everybody else who has no idea what the hell's going on, but you do. You're like, oh, I know what's going on, and then you're like, oh, you're confused. Huh? So are you. Oh, well, the whole row in the back, yeah, they have no idea what's going on. Yeah, well, I guess I'm the only one getting an A here. You know, so, it's kind of hard to believe at this point that that's going to happen.
Just knocking out the confusion now.
That's the idea. Yeah, you're having the growing pains at this point, so that you won't have it when push comes to shove. And, yeah, so when you're paying money to take classes, let's think of it that way. You know, and I don't want to get too far down the college road, but they don't care if you fail. Actually, I honestly think they want you to, because then you have to pay for the course again. So let's say you had to take a course 3 times, and it's roughly $1,000 a credit, 4-credit math course, $4,000. So the first time it's part of your tuition. The second time you're paying it on top of tuition. And the third time, if you have to take it a third time to pass, yeah, you're basically paying $8,000 extra for the same 4 credits. You know, you don't get extra credits. You know, so from their perspective, they don't mind if you fail. Right? So that's pretty sad. And it's on my mind now. I really don't want to go down this road too much, but it's on my mind now because I just got through grading one version of my Cal 3 exams, and it wasn't pretty. It wasn't pretty, but I also looked at their opening surveys because I haven't, like we did in this class. I know it was a long time ago, but I haven't completed a survey of what class did you take before this one? How'd you do in that class? And 70% of the class that I'm teaching failed the class already. So they're taking Cal 3 for the second time with me. And it's not going any better this time. So, if it's a degree requirement, yes. And it's a crapshoot over what teacher you're gonna get. So ratemyprofessor.com is a really good approach to take. Like in high school, you might have heard ratemyteacher.com. It's useless, right?
Yeah.
You look at it, doesn't really tell you much anything. And the only people who post anything on that are the ones that either really like the teacher or really hated the teacher. The ones that are indifferent, they don't post anything. But in college, everybody kind of looks at it as their responsibility to kind of pay it forward. So you get more meaningful reviews on ratemyprofessor.com. I'm very highly rated, so it's worth checking out. Anyway, antiderivative. Left-hand side, as you know, because we just did it, is going to become a P. The right-hand side, you may want to clean it up a little bit first. So I'm going to write this as P equals the antiderivative of 25k minus tk dt. And actually, you know what? Let me write that as kt. It really doesn't matter, but if I want it to be in the nice power rule form, this is going to serve us better. So P would be equal to 25 kt minus k over 2 t squared plus c. All right, in both cases it was the reverse power rule. So I increase, I'll just focus on the kt, increase the exponent by 1, divide by the new exponent. All right, in the case of the 25k, as long as you train yourself to think of k as being a constant, you're looking at 25k as being the product of two constants. The antiderivative of a constant is the constant multiplied by the variable. All right, so this is our solution to the differential equation, and obviously more challenging if the function is more challenging, and also if I had to figure out what k and c are, you know, it could be more of a ride, but the process should not be the confusing part. Like knowing what steps to follow, that should not be the confusing part. If you're going to get jammed up, it's going to be in this one from step 2 to step 3. Your lips to God's ears, buddy.